Okay, let's go ahead and solve for the transfer function of this high pass filter, also denoted as V out of omega over Vs of omega, which is also equated to H of omega. Now, there's many ways to solve this, but what I'm going to do is use a method called KVL, which is Kirchhoff voltage law, or a fundamental to mesh analysis. And I'm going to say that I have a current flowing through my circuit, I of t, where I get a plus minus here and a plus minus here. And essentially, KVL just tells us to solve for voltages across the loop. So this becomes minus Vs of omega in the frequency domain plus I of omega times 1 over j omega c plus V out of omega has to equate to 0. Now, this I of omega can be written as simply V out of omega over R. So I'm going to go ahead and plug that in to my equation. So then I get minus Vs of omega plus V out of omega over R times 1 over j omega c plus V out of omega has to equate to 0. Now let me go ahead and pull out a V out of omega and say then that this is 1 plus 1 over j omega c times R has to equate to Vs of omega. And now I can write my final answer by saying that V out of omega over Vs of omega, which is also equals to H of omega, is simply j omega c times R over j omega c times R plus 1. And as you can see, if I put a DC source or omega is equals to 0, I get 0 over 0 plus 1, which is simply just 0. And as a result, no DC source or low frequency will pass through. But then if I replace this with omega is equals to infinity or a high frequency, I would get infinity over infinity, which is simply just 1. So that means high frequencies will pass through. That's why it's called a high pass filter. Thank you.